Hello everyone, I'm Syed. I am here to present a paper which has been accepted in SusTech 2024. So let me share my screen. So the name of the paper is The Inventor Price of Intelligence, Evaluating the Social Cost of Carbon in Machine Learning. So the motivation behind is that the ML application is on rise and so the carbon emission, and which is now become a major concern. One study found that the GPT-3 training emits around 2000 kg of carbon dioxide, which is roughly equivalent to 40 cars in 1 year. So this is a big number. So what is the reason behind the carbon emission? So researchers found that the floating operation are the main cause of energy consumption, which thus increase the carbon emission. There are a lot of methods to calculate carbon emission, such as carbon accounting, which means to measure the carbon of a certain organization in a certain amount of time, which can help policymaker to evaluate the carbon emission and put some uh, restriction on that. And there is another terminology called carbon budget, which is the maximum allowed carbon emission, so that the temperature doesn't raise to a certain level. Scientists have determined that maximum allowable temperature rise is 1.5 to 2 degrees Celsius. If it is become more than 1.5 to 2 degrees Celsius, it will have a catastrophic effect in the world. And there is another method called carbon offsetting, which means you compensate for the carbon emission. Let's say you emit 2000 kg of carbon dioxide, so you will plant equivalent amount of trees so that the carbon emission is reduced and overall the net carbon emission becomes zero. There is another method called life cycle assessment, which means assessing carbon emission from the product life cycle, from the development to disposal. There is another method known as defensive consumer pattern, which denotes as the effect of temperature rise in future. So if the temperature rise to 2.5 degrees Celsius, what will happen in future? This is a good metric. And there is another method named green computing, which means producing sustainable hardware so that it is more, it doesn't affect the carbon emission in the future. So what's our contribution? We propose a metric called social cost of carbon to calculate carbon emission of ML models. It is a metric derived from the dynamic integrated climate economic model, which is known as DICE model, which is developed by a Nobel laureate named William Norharas. It is a neoclassical economic model, which is a integrated assessment model because it integrates different modules like climate, economic, and policy module to evaluate the cost of carbon emission. So what is the social cost? What is the definition of social cost of carbon? Social cost of carbon means measuring a carbon emission of each ton of carbon dioxide in dollar value. So if and it also depends on the discount rate, which is subject to the future value. So what is discount rate? Discount rate is a financial metric used to correlate future value to present value. Let's say the present value is lower, so the present. So based on the discount rate, let's say discount rate is 1.5%. So evaluator put more emphasis of present value than future value. So with the increase of discount rate, we can see that decrease of social cost of carbon in future. So if we test our methodology, we use the MNIST dataset. MNIST is a widely used dataset for machine learning. It has a handwritten digit from 0 to 9, and it has 28 x 28 pixels grayscale images. And for emission tracking, we use Code Carbon. Code Carbon is a Python library which easily integrates with the Python course, so that we can track emission, carbon, and different other metrics. For classification, for the MNIST class, we use deep neural network, which we implemented in TensorFlow. So we tested with the different orientation like hidden layers, optimized a number of training reports. So what we do, we created different hidden layers from 1 to 4, a number of hidden layers, and then we use different kind of optimizers and which we train our model through different epoch from 5 to 40 with the increase of 5. So and we measure the carbon emission. So overall process is summarized on this picture. We first initialize a carbon emission tracker. There are a lot of code carbon. There are three methods to. There are three different methods to track carbon emission in code carbon. We use the tracker-based carbon emission. Then we put the carbon emission of each of the phases, like data collection, data processing, model training, and model testing. We don't have any access to model deployment phase, so we only consider this 4 phase for machine learning emission. Then code carbon will track the carbon emission and log to the CSV file. Then we further analyze the CSV file for carbon emission. So based on our empirical result, we found that a four hidden layer is the best for classification, but as it yields more higher accuracy. As you can see in this graph, that with the increase of epoch, the accuracy keep increases. So the 40 epoch yields the highest accuracy, highest both training and test accuracy. So we take the 40 epoch to demonstrate our further results. And as we can see, most of the emission causes in training phases, and other phases also correlate the emission, but it is not not bigger than the training emission. So this is our model ML model structures, and we have 4 hidden layers which use activation layer ReLU, and the output layer which uses activation layer softmax. So how do we calculate the social cost of carbon? So we calculate the social cost of carbon in gram equivalent through this equation, where we multiply weighted average of emission of carbon dioxide source times the energy, which is the total overall emission in gram carbon equivalent or kilowatt hour. But we need to convert it to social carbon. According to the definition, social cost of carbon need to be converted in tons. So we convert gram emission to the ton, and then we multiply with the discount rate. So we take only discount rate of 2.5%, which is roughly equivalent to $120. And then we showed the result of the fourth layer DNN classifiers, fourth hidden layer DNN classifiers. As we can see, with the increase of epoch, the emission keep rising, and so do the social cost of carbon. And it also depends on the optimizer. Different optimizer have different emission level, and it will cost differently as in terms of monetary value. So we summarized our result in this graph, and we can see that the optimizer selection has an impact on carbon emission. So different optimizer, as you can see, aggregate emission causes the highest emission, and ANAM is causing the less emission in overall scenario. And we plot the different emission, and we see that with the increase of epoch, the emission keep increasing, and so do the social cost of carbon. And we plotted it with a different optimizer, and we also see that there is the effect of number of layers for carbon emission. With the number of layers, increased number of layers, the social cost of carbon dioxide keep increasing. So our contribution is that calculating social cost, integrating social cost of carbon in carbon emission tracking, which can help policymakers to evaluate environmental cost of carbon emission in dollar, and different model orientation. And it will help us to analyze the ML integration framework and understand it more closely. So for future work, we'll focus on different orientation of carbon ML models, so that we can understand more about the carbon emission, and also research on the different carbon emission metrics, so that we can analyze more and quantify carbon emission more clearly and effectively. These are some of the references we use, and thank you all for your attention.